The sun shines because of nuclear fusion. In a nutshell, fusion is a thermonuclear process, meaning that the ingredients have to be incredibly hot, so hot that the atoms are stripped of their electrons, making a plasma where nuclei and electrons bounce around freely. Since nuclei are all positively charged, they repel each other. In order to overcome this repulsion, the particles have to be going very, very fast. In this context, very fast means very hot. Millions of degrees. Stars cheat to reach these temperatures. They are so massive that the pressure in their cores generates the heat to squeeze the nuclei together until they merge and fuse, creating heavier nuclei and releasing energy in the process. It is this energy release that scientists hope to harness in a new generation of power plant, the fusion reactor. On Earth, it's not feasible to use this brute force method to create fusion, so if we wanted to build a reactor that generates energy from fusion, we have to get clever. To date, scientists have invented two ways of making plasmas hot enough to fuse. The first type of reactor uses a magnetic field to squeeze a plasma in a donut-shaped chamber where the reactions take place. These magnetic confinement reactors, such as the ITER reactor in France, use superconducting electromagnets cooled with liquid helium to within a few degrees of absolute zero, meaning they host some of the biggest temperature gradients in the known universe. The second type, called inertial confinement, uses pulses from superpowered lasers to heat the surface of a pellet of fuel, imploding it, briefly making the fuel hot and dense enough to fuse. In fact, one of the most powerful lasers in the world is used for fusion experiments at the National Ignition Facility in the US. These experiments and others like them around the world are today just experiments. Scientists are still developing the technology.